Welcome to True Projects. In this video, we are going to explain about the project that is intrusion detection for wireless sensor network using particle swarm optimization based explainable ensemble machine learning approach. So before getting into the execution, first let us understand what is this project about. Wireless sensor networks, or we call them as WSNs. They are basically networks made up of tiny sensor devices. Think of them as little gadgets spread out of in different places, and their job is to collect information like temperature, movement, or pressure and send it to central system. They are super useful because they don't cost much and they don't use a lot of power and they can work in flexible setups. That's why you see them being used in so many fields like monitoring the environment, ensuring security, tracking patients' health, or even in industries to keep an eye on machines. But here the problem is these sensors are small and lightweight, so they don't have much computing power or storage. They can't really handle heavy tasks, plus, their ability to communicate with each other is limited. Because of these weaknesses, they are easy targets for the intruders or the hackers. So, while WSNs are really powerful tools, their vulnerability makes security a big concern. So, here, the problem with securing wireless sensor networks is that attacks are getting smarter and more complicated over time. One big issue is that most of the data in these networks is just normal everyday activity and only a small fraction is actually malicious. Because of this imbalance, the system sometimes struggle to catch those rare but important attack cases. And on top of that, these networks often have a huge number of sensor nodes, which makes the system harder to manage and more complex to scale. Another problem is false alarms. Sometimes the system flags normal behavior as an attack, which creates confusion, and when new or unexpected attack types come up, many systems fail to adapt quickly. And to make things and here to make things more complicated, a lot of machine learning models that are used for intrusion detection act like black boxes. They might tell you something is wrong, but they don't explain why they came to that conclusion. This lack of clarity makes it hard for people to fully trust the system. So that's why it is so important to address these issues because only then can wireless sensor networks be reliable, secure, and effective in real world use. So to make wireless sensor networks more secure, this project builds a smart intrusion detection system, or we call it as IDS. So the idea here is to catch any unauthorized or suspicious activity in the network, and the system is designed to be accurate, fast, and easy to understand. So first, it uses something called ensemble machine learning approach. Think of it like asking three experts for their opinion instead of just one. Here, the experts are three different models, that is, random forest, decision tree, and k nearest neighbor. Each of them look at the data in a slightly different way. Then the system combines their opinions using soft voting method, which basically means it weighs everyone's input to make a more reliable decision. This helps to reduce mistakes and make detection stronger. Then, second, the system uses particle swarm optimization. Here we can imagine PSO like group of birds flying around looking for the best spot to settle. In this case, it helps the model finding the best settings, that is best hyperparameters, to perform at their best. By doing this, the system becomes more accurate, adapts for better to different attack types, and works well even when the attacks are tricky or unusual. And the other challenge that with detecting intrusions in these networks is that most of the data is normal activity. So most of the data is normal activity and only small portion is actual attacks. This makes it hard for the system to learn and recognize the rare attacks. To fix this, the project uses something called SMOT, that is synthetic minority oversampling technique with TOMIC. SMOT it works by creating fake or synthetic examples of these rare attack cases so that system has more examples to learn from. Think of it like practicing with extra training examples to get better at spotting rare mistakes. Coming to Tomic links, these help by cleaning up confusing or broadline data points that could make the model confused. It is like removing misleading or noisy examples so the learning is clearer. Together, SMOT and Tomic links make the data set more balanced, which means system can better detect those rare but important attacks. And on top of that, in this project, the project also focuses on explainable AI. Many AI models are like black boxes. They give you prediction, but they don't give you why it is made. To solve this, the system uses LIME and SHAP, which are the techniques that explain how the model made its decision. So we have used LIME, which is interpretable model agnostic explanations, local interpretable model agnostics. So this explains individual predictions showing why the system flagged a particular input as an attack. Then coming to SHAP, it is Shapley additive explanations. It gives a bigger picture showing which features are generally most important for the model's decisions. So this makes the system more that is not only just accurate but also transparent and trustworthy because users can see why it made a particular prediction. And to further improve the performance of this project, here we are incorporating other ensemble model that is called stacking classifier. This model also have team of machine learning algorithms where each machine learning algorithm looks at the data in their own way and then a final meta model it combines their opinions to make a final decision. This approach makes the prediction stronger and more accurate because it leverages the strength of all the individual models together. It is especially useful when we're trying in different ways of reducing features in the data. Then we have developed user-friendly interface by using Flash framework with the user authentication so that users can interact with the system. This interface has user authentication, which means it is secure and only authorized users can access it. Through this interface, users can enter their own data and the system will give predictions based on the trained models. So instead of just running the model in code, anyone can use it conveniently through a web app. Moving on to the implementation. To implement this project, here we have steps which are mentioned in the flow of work. So we have followed these steps to execute this, that is to implement this project. So first we have imported all the necessary Python libraries and tools that will help us in processing, training and building the system. Then comes data ingestion. At this step, we load the wireless sensor network data into Pandas data frame, which makes it easier to work with and manipulate the data for further steps. Then comes pre-processing. At this stage, we handle many missing values by either filling them or removing them, and we convert categorical data into numbers using label encoding so the models can understand it. Then we standardize numeric features so all values are on similar scale, which helps to improve the model performance. Then comes optimization, that is model optimization. So here we will be using particle swarm optimization to automatically find the best setting for our models. And we will be applying grid search CV to systematically check different parameters, combinations, and select the optimal ones. Then comes data resampling technique. So here we will be balancing the dataset using SMOTE and SMOTE to make, which create additional samples for rare attack cases and remove confusing ones. So the model can learn better. And then we split the data into training and testing sets, where training set is used to train the model and testing set is used to evaluate the model. Coming to model training, here we will be training severe model, that is several models that are decision tree, random forest, KNN, and the ensemble approaches like voting and stacking classifier to detect intrusions. Then comes model evaluation. So at this stage, we measure performance of all the models using accuracy, precision, recall, and FN score, and we use confusion matrix to see where the model makes mistakes like false positives or false negatives. And we apply SHAP and LIME to interpret the model's decisions and make the predictions understandable and transparent. Then we will be saving the best performing model for the future use. And also we save the standard scalar and label encoded so that new input data can be processed consistently when we are deploying. Coming to the Flash based web application. So here we will be creating, we have created an input form for users to provide features. And at the back end, we will be loading the saved model, scalar and encoder and pre-process the user input. So the given input, it will be pre-processed at the back end. It will be fed to the train model and then train model will be giving us a prediction predicting the attack. So this is how we have implemented and these are the models used in this project. And to implement this project, basically we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4 have been used. Now let us execute. Because this is the overview of the project, we are done with the overview. Now let's execute it. To execute, open the code folder that contains source code files. So These are the source code files of this project. And in this folder, we have the dataset that is used. So this is the dataset that is used. It's opening. Just wait for a while. Until it opens, let's understand the other files. Get back. And here we have model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder. In this folder, we have CSS, JavaScript, and Bootstrap files, which are important for the project's visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And in this, we have test cases that we will be using in the front end. Here we have app.py file. So this .py file contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have notebook file, which is a Jupyter notebook file, and it contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Dataset has been opened. So here we have different features based on which we will be predicting the attack type. So here we have label, which is target class. So based on these attributes, we will be predicting this target variable, and we will be training data on this data only to predict the attack. Close it. And now let's execute. To execute, copy the path of the code folder from the address bar of the file explorer. So copy the path. Now open Anaconda prompt. It is open. Now give the command cd, give the space, paste the copied path, click on enter. Here if you observe, current directory is changed to the code folders path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flash framework will host the application locally at the default address, which is the local host, and the port unless configured differently. So just wait for a while. File is being compiled. So here at this address, application has been hosted. So copy this link provided by the Flash framework. I've copied it and paste it into any web browser. I prefer Chrome, so I will paste it in that. Paste the link here and click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So this is the web page. Now we need to get signed up. So click on sign up and create an account by filling all these details. I have already created, so I'll directly sign in. Click on sign in. Give your username and the password, and then click on sign in. We have signed in successfully and redirected to prediction page of the project. So here you can see multiple parameters, right? So these are the parameters need to be entered for predicting the network attack. Let's understand these parameters. So first we have node ID. It's a unique identifier assigned to each sensor node in a network. Then we have time. Time is the timestamp or specific time when the data is recorded or an event occurs. Then we have is cluster head. It it indicates whether the node is acting as a cluster head, that is the leader of group of nodes. Then we have who is cluster head. Here we have who is cluster head. So it shows which node is the cluster head that this node belongs to. Then we have distance to cluster head. This is the distance between the node and it is assigned cluster head. Then we have advertisement sent. It is the number of advertisement messages this node has sent to notify the other nodes. Then we have advertisement received. So this is the number of advertisement messages the node has received from the other nodes. Then we have join request sent. So this is the number of requests sent by this node to join cluster. Then we have join request received. It is the number of join requests this node has received from the other nodes. Then we have schedule sent. So this is the number of schedule messages. That is the number of schedule messages the node has sent using for coordinating communication. Then we have schedule received. It is the number of scheduled messages received by the node. Then we have node rank. So this is a metric showing the model importance or priority within the cluster. Then we have data sent. It is the amount of data transmitted by the node to the other nodes. Then we have data received. It is the amount of data the node has received from the other nodes. Then we have data sent to the base station. It is the data sent from the node or the cluster head directly to the main base station. Then we have distance CH to base station. It is the distance between cluster head and the base station. Then we have send code. It is a code indicating the type of message or the data sent by the node. Then we have consumed energy. It is the amount of energy or battery the node has used so far. So this is all about the parameters. Now let's enter them. For that, let's open sample file. So open test cases, open test data. So here we have multiple inputs that we are supposed to give. And here we have total 5 different types of targets. Let's apply filter to target column. Let's check with the target 0. Let's enter. So copy the node ID and paste it. And then we have not copied. Let's copy it again. Let's copy it now, paste it. And then we have time, that is 1.18, and is cluster head, it is 0.03. And then we have who is cluster head, copy it and paste it. And then distance to cluster head, advertisement sent is minus 0.034, and advertisement is 1.21. And here we have join request sent, join request received, schedule sent, and we have schedule received, node rank, here we have to enter it, and then data sent, data received, data sent to the base station, distance from cluster head to the base station, send code, and here we have consumer energy, consumed energy. Now click on submit network data. So this given information, it will be pre-processed at the backend, it will be fed to the train model, and then train model will be giving us a prediction. So here you can see black hole threat has been predicted. So black hole attack detected where malicious nodes drop or redirect network packets causes data loss and communication disruption. This is about black hole attack. And here we have confidence score of 99.4%. And here we have technical analysis where network status is unstable, data flow is irregular, energy consumption is high, and cluster head is compromised. So here you can see cluster head has been compromised. And here we have network metrics where advertisement messages are of 85%, join requests are 92%, data transmission is 78%. And here we have recommendation where immediate investigation, security response, recovery planning are needed. Let's try predicting the other class. So click on new class and let's give the one target and let's enter them where node ID is 1.26. In this way, I'll be entering all the values. So here I have entered all the parameters and now click on submit network data. And here you can see flooding attack has been predicted, which is a threat. Flooding attack detected with excessive network traffic patterns that may overwhelm network resources and cause service degradation. So here, this is about flooding attack. And here we have confidence score of 99.9%. And network analysis is network status is unstable, data flow is irregular, energy consumption is high, and cluster head is compromised. And here we have network metrics that are advertisement messages, join request, data transmission, and here we have recommendations. Let's try predicting new case. Now let's try with class 2. So apply filter to class 2. Click on OK. Let's check with this case where copy the node ID, paste it, paste the time. In this way, I will be entering all the values. So here I have entered all the values. Now let's click on submit network data. And here we got the prediction as gray hole threat. So the network type of that is network attack, it is gray hole type of attack. And gray hole attack detected with selective packet dropping behavior that can cause intermittent network connectivity issues. And here we have confidence score of 99.3. And here we have technical analysis. Here we have network metrics. And here we have recommendations. Now let's do the new analysis. So let's apply filter to class 3 and click on OK. Let's fill in all these values where node ID is minus 4.729 and cluster head, sorry, time minus 1.10, cluster head minus 1.194. Who's the cluster head? And then distance to cluster head, advertisement number, that is advertisement sent, advertisement received, and join request sent, join request received, schedule sent, schedule received, node rank, data sent, data received, data sent to base station, data from cluster, that is distance from cluster to base station, sent code, and consumer, that is consumed energy. Paste it. Now click on submit network data. And here we got the prediction that it is normal. There is no attack. So here the network analysis indicates that wireless sensor network is operating with normal parameters with no signs of intrusion malicious activity detected. And here we have confidence score. Here we have technical analysis that network status is stable, data flow is regular, energy consumption is optimal, and cluster head is also active. And here we have network metrics. And here we have recommendations. Now let's check with the last case. So apply filter to target 4 and click on OK. And let's fill in all these values. So select the node ID, paste it. Then time is minus 0.5. Then we have cluster head is 0.5. And host cluster head is minus 0.73. And then distance to cluster head it is minus 0.3. Advertisement sent is also minus 0.3 with the decimal points. Advertisements received, advertisements sent. We have missed something, so just wait. Yeah, here joins request sent, join request received, scheduled sent, schedule received, node rank, data sent, data received, data sent to base station, distance from cluster head to the base station, and then sent code, consumed energy. That is minus 0.6. Now click on submit network data. And here we got the prediction that is TDMA attack has been detected. TDMA warning here we have. So TDMA is time divisible, that is time division multiple access protocol behavior detected, which may indicate normal scheduling or potential timing based attacks. And here we have confidence score, and here we have technical analysis that network status is unstable, data flow is irregular, and all the things. Here we have network metrics, and here we have recommendations. Now let's check with the graph. So click on graph, and here you can see the graphs. So here on x-axis, we have all the type of attacks, all the targets that we are predicting, and on y-axis, we have count. Here, if you observe, we have normal cases more than the other attacks. So that is why we are using data balancing technique. That is Mortein. SMOTMIC. And here we have confusion matrix with ROC. So this is the confusion matrix and this is the ROC curve graph. And here we have accuracy comparison graph, where on x-axis we have all the models that we have trained and on y-axis we have accuracy score. And here we have recession comparison graph. Here we have recall. And here we have FN score. And here we have XAI SHAP. This is XAI SHAP comparison graph. Here on x-axis we have SHAP value and on y-axis we have the features. Now close this. Click on sign out. So in this project, we built a smart system that helps to keep wireless sensor networks safe and reliable. It can detect unusual activity, prevent potential threats, and give a clear explanation for its decisions, making this network more secure and trustworthy. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.